As a researcher, you're going to perform an experiment. I'm kind of hungry right now, so let's say your experiment will examine 4 people's ability to throw a ball when they haven't eaten for a specific period of time: 6, 12, 18, and 24 hours. We can say that in your experiment, you're going to do something and then see what happens to other things. But that sentence isn't very scientific, so we're going to learn some new words to replace the unscientific ones, so we can provide a scientific explanation for what you're going to do in your experiment. The starting point here is to identify what a variable is. A variable is defined as anything that has a quantity or quality that varies. Your experiment's variables are not eating and throwing a ball. Now, let's science up that earlier statement. You are going to manipulate a variable to see what happens to another variable. It still isn't quite right because we're using the blandest term for variable and we didn't differentiate between the variable. Let's take a look at some other terms that will help us make this statement more scientific and specific. A moment ago we discussed the 2 variables in our experiment, hunger and throwing a ball, but they are both better defined by terms dependent or independent variable. The dependent variable is the variable a researcher is interested in. The changes to the dependent variable is what the researcher is trying to measure with all their fancy techniques. In our example, your dependent variable is the person's ability to throw a ball. We're trying to measure the change in ball throwing as influenced by hunger. An independent variable is a variable believed to affect the dependent variable. This is the variable that you, the researcher, will manipulate to see if it makes the dependent variable change. In our example of hungry people throwing a ball, our independent variable is how long it's been since they've eaten. To reiterate, the independent variable is the thing over which the researcher has control and is manipulating. In this experiment, the researcher is controlling the food intake of the participant. The dependent variable is believed to be dependent on the independent variable. Your experiment's dependent variable is the ball throwing, which will hopefully change due to the independent variable. So now our scientific sentence is, you are going to manipulate an independent variable to see what happens to the dependent variable. Sometimes when you're studying a dependent variable, your results don't make any sense. For instance, what if people in one group are doing amazingly well, while the other groups are doing about the same? This could be caused by a confounding variable, defined as an interference caused by another variable. In our unusually competent group example, the confounding variable could be that this group is made up of players from the baseball team. In our original example of hungry people throwing the ball, there are several confounding variables we need to make sure we account for. Some examples would be metabolism and weight of the individuals. For example, a 90-pound woman not eating for 24 hours compared to a 350-pound man not eating for 6 hours. Ball size. People with smaller hands may have a difficult time handling a large ball. And age. A 90-year-old person will perform differently than a 19-year-old person. Confounding variables are a specific type of extraneous variable. Extraneous variables are defined as any variable other than the independent and dependent variable. So a confounding variable is a variable that could strongly influence your study, while extraneous variables are weaker and typically influence your experiment in a lesser way. Some examples from our ball throwing study include time of year, location of the experiment, and the person providing instructions. Our scientific sentence is now, you're going to manipulate the independent variable to see what happens to the dependent variable, controlling for confounding or extraneous variables. In an experiment, if you have multiple trials, you want to reduce the number of changes between each trial. If you tell the ball throwers on the first day to toss a ping pong ball into a little red cup, and on the second day you tell ball throwers to hurl a bowling ball into a barrel, your results are going to be different. Each experiment has control variables, which are variables that are kept the same in each trial. These would be things like ball size and weight, number of people in each trial, where participants are throwing the ball, and instructions of what to do. Moderator variables are variables that can increase or decrease the relationship between the independent and dependent variable. These are often identified when repeating an experiment or coming at it from a different angle. In our ball throwing example, if you secretly placed a research assistant, someone who works for you, among the participants and made them complain loudly about how bad they're failing, this would likely make everyone else's ball throwing worse. These are not necessarily bad things, but they will change your final result. So now the scientific version of our first sentence will read like this. A researcher manipulates the independent variable with the goal of measuring changes in the dependent variable while accounting for and controlling confounding, extraneous, and moderator variables by using control variables. A variable is defined as anything that has a quantity or quality that varies. The dependent variable is the variable a researcher is interested in. And the independent variable is a variable believed to affect the dependent variable. Confounding variables are defined as interference caused by another variable. Extraneous variables are defined as any variable other than the independent and dependent variable. Control variables are variables that are kept the same in each trial. Lastly, the moderator variables are variables that increase or decrease the relationship between the independent and dependent variable.